Question 1, we are done with question 1. Now we are going for question number 2.
Yes.
Okay, this is question number 2. Question number 1, we are done. Question number 2. So it's saying a traveling wave is described by, so this is a wave that is a traveling wave, and there are two variables. It's varying x at the same time with time. So y of x of t, yx of t, which means there is a comma there in between x and t, which means it's as a function of x and t. It's multivariable. It's not only as a function of y of x only. So this is a multivariable function. It's depending on x at the same time, depending on what? T. Are we together?
Yes.
Hello?
Hello.
Yes. So that function, it has two variables at the same time, x and t. They are all variables. So it's given by 0,2 e to the exponent minus x minus 3t sine x plus 3t. That is the wave which you have been given here. For x, we have been given that for x and y measured in what? In centimeters. So x and y are measured in what? Centimeters. And also t is being measured in what? In seconds. So the question is saying, show explicitly that y of xt satisfies the one-dimensional wave equation. So first you must know that definition of that one-dimensional wave equation. What are the characteristics of the one-dimensional wave equation so that it can be satisfied? So first you must know if this equation satisfies this one-dimensional wave equation. What are the characteristics of that wave, one-dimensional wave equation, so that it can be satisfied? That is point number 1. Then deduce the wave speed from this. So deduce the wave speed from this. What is the direction of propagation? So what is the direction? Remember, when we used to do maths, we used to say a shift in the x. If you are given, maybe it's a quadratic equation, y is equals to x minus 3 squared. And then you are given another one, y is equals to x plus 3 squared. Which graph has been shifted to the left? Which one has been shifted to the right? If you still remember these shifts. We normally used to say, if there was a negative, it means it has been shifted 3 units to the what?
To the left.
Is it to the left for the first one? For A and B?
A is the left.
For A, for A, it's the right.
It's the right.
Yes, which
Yeah.
means your turning point, it's now at 3. Instead of it being at what? It would be like this. The turning point is now 3 units to the right. It's the opposite. Where there is x here, you know it's 3 units to the what? To the right. So which means that graph will be for A. The one that has been shifted to the left, That is the one that will be having the positive one. Like this one. Now it has been shifted to the left, which means it will cut from here, -3, like that. So this is -3. If the graph has not been shifted, it's just y is equals to x squared. Without any shift, it's standing at origin. There, at origin, facing upwards. If you shift the graph to the right, so this is to the right. If you shift the graph to the left, here it's going to be what? Positive. It's the opposite of the way you are thinking. Isn't it? You forgotten? Have you forgotten your matric maths? So that one is A. This one is what?
B.
B. So it applies also to sine. Sine x plus 3t, which means you have shifted to the left. So this plus, it indicates the direction of propagation. It's towards the negative. Okay, the plus. So we'll discuss about that when you are answering. So first we must have the wave equation, the standard one for the one-dimensional wave. And you must refresh your memory about these graphs. Where shift to the right, it's not plus. Plus only applies when shift to the up in the y-axis. If it's up, it's plus. If it's down, it's minus. But when it comes to equation of a circle, sine wave, cosine, a shift in the x to the right, it's minus. A shift to the left, we call it a plus. So you must take note of that, isn't it?
Yes.
Yeah. So let's start with our question. These were just basics which we need when we are approaching this question, so that you won't be asking why is it shifting to the left, yet there is a minus and there's a plus. So I've already clarified to say when it's positive, it's to the left. It's the opposite of how we are thinking here in terms of x always. When you see it's sign x minus 3t, then you know the propagation of this wave is to the what? To the right, or to the positive x displacement. It's moving to the right or to the positive x displacement. Negative, yeah. That's all. All right. And then, now, hello. There's a question.
Sorry.
Yeah.
It's me. It's a mistake.
Oh. So when you are verifying this one-dimensional wave, we want to verify this point. This is what we want to verify here. Can you see? Where the second partial derivative with respect to time. The second partial derivative with respect to time. It must be in this format. Remember, we said our function y is in form of x and what? And t. So now you can say dy dt. Dy dt is only for one variable. You get what I'm saying? Or you can say d squared y dt. This only works if y was a function of x only. Because now y is a function of two variables. That's why you are going to use partial. So you must write your d like this. Partial squared y over partial t squared. It's not a d, this one. It's a partial derivative. So you must know the difference. We only use this d if your function is only having one what? Variable. Do you get me? Hello? Are we together on notation there? Only the notation. I'm just clarifying on the notation of writing. When you're writing with your pen, you don't have to write what is it? D squared. You are not allowed to write D squared Y over D T squared, which means the second derivative with respect to time. This is not correct. Why? Because our function is two variables. So we are supposed to write it like this, which is a partial. A partial, the D that is bent like that. Partial derivative of Y, second partial derivative of Y with respect to time, which is partial T squared. Can you see how I wrote here? Can you see my D? Are we together?
No. So
This
the formula.
The
Well,
D, I'm not talking about formula, I'm still talking about the notation of writing. The D of partial and the D of derivative. This is the derivative and this is a partial derivative. We are just talking about the notation. We are not yet on the formula yet.
okay.
Yes, so this from mathematics you must know, from calculus. From partial derivatives and the difference between the derivative for one function. This one is we are deriving a partial because it's a two variable function. Partial and the derivative D for one variable. That's what I'm just saying. I have not mentioned anything about the formula. I'm just on notation only on how you are going to write, because if you write wrongly, you'll be penalized. Where you are supposed to write a partial, you see yourself writing a D. So you'll be penalized for that. So you must know that you are going to write not a D, but it's a partial like that, which is this one. You write a partial in terms of writing. You don't write a D, it's a partial like that. If it's partial squared, then you write partial squared. If it's just partial Y, you write partial Y. That's what I'm just saying. Partial derivative. All right, so for one-dimensional derivative, what is it that we are saying? We are saying that if a wave is one-dimensional, it must satisfy this condition. Are we together?
Hmm.
If a wave is one-dimensional, it must satisfy what? That condition, whereby this V squared is just a constant, which is just a number, this one. So in other words, we want a partial squared, which means the second derivative of Y with respect to time must be equals to a constant. That constant is V squared, which is speed, the speed of that wave. And it must be also equal to the partial, which means the second derivative of the same function Y with respect to what? Now it's respect to X, not to time. So this question is more of maths. If your maths is good, then you understand the problem. But if your mathematics is not good, you are going to have a problem in understanding this question, because it wants you to perform mathematical calculations on derivatives, partial derivatives. So what are we trying to do? We are trying to arrive at this step where the second partial derivative of Y with respect to time is equals to the second derivative of Y with respect to X, the position. X is the position, Y is the function with respect to time. You derive and then you are going to get X with respect to time. The number that will be left here is just a constant. You equate it to V squared. That will be the speed. That's what we want to do. So let's start. So first, we derive this one. The first equation, we are given our equation. It's Y of X is equals to this. So what is partial? We are differentiating y with respect to x, while we are keeping t what? As a constant. So we are saying t is a constant, but we are differentiating with respect to x. How to get? Anyone want to
Yes.
try? Anyone want to try? Partial y with respect to partial x. T is a what?
It's
Is a constant. So your variable now is only x. What answer are you going to get?
0,
Equals to 0,
2 bracket
e to the power what?
e to the power negative t.
Remember we said a constant is what?
It's I. It's
The
what?
constant t. T is a constant.
Yeah.
The only
So that -1, that negative x is gonna be 1. So which is gonna be, we're gonna be left with negative t. I'm not sure about the negative side. The negative -1, but we'll be left with negative 3t.
You mean here?
No, the first part, the e to the power negative x, that x is gonna change to be 1 because we need to multiply with it. So it's gonna be 1. And we are left with negative 3.
Yeah, correct. Let me just make it more easy so that you can see this is the same as 0, 2 e to the power minus x multiplied by e to the power minus what?
Negative
3t. This we are multiplying here, the dot for multiplying. And then you continue the whole story, which is sine bracket x plus 3t. So what we are saying 0, 2 and this, they are just constants, isn't it? We can put them outside the what?
The bracket.
The bracket. Like, then you differentiate only e to the power negative x. So you get minus e to the power negative x because it does not change. So what is outside the exponent is 0, 2 e to the power minus 3t, which is a what? A constant. Okay? Then you are having e to the power minus x. But when you differentiate e to the power minus x, it's going to give you e to the power minus x multiplied by the derivative of this minus x, which is minus what? -1. So that's why the -1 is outside the bracket there. So which means you are going to put -1 outside here, the bracket. Then when you differentiate sine with respect to x, what are you going to get?
Negative cos x plus 3t.
For differentiating sine, do you get negative? Or for sine, you get cos?
No, you go positive cos x and then plus
cos 3, cos x plus what?
Plus 3t.
X plus 3t. We close our bracket. Then when you differentiate what is inside the bracket, it's going to multiply here in front of the cos. So if you differentiate x plus 3t, you are going to get 1. Differentiate 1, x, you get 1. So the 1 here, you are going to multiply by 1. Any number times 1 stays the same. That's why it didn't change.
Yeah.
Then if you differentiate 3t, we said 3t is a constant. It's 0. So it will be 1 plus 0. So you find out you are just left with this one only. Okay, are we happy?
Yes.
That is our first partial derivative with respect to
X.
y. To x. Yes, y with respect to x. So we come here. So here is cos 3 cos x plus 3 bracket, and then you close. All right. So they are differentiating with respect to t. Then at the end, are we getting the same answer? If you differentiate x, y with respect to x, t is a constant. Did you see it? Hello?
See what? Are you
I'm saying,
differentiating with respect to t now?
isn't it? When we are differentiating this one, we were differentiating only the part which was the second part. Remember, when we are differentiating this, it's a product rule, isn't it? We are having two variables, e and what? E and sign. There are two variables, e and sign. So it's a product rule. You differentiate the first one, you keep the other one constant. Plus, you differentiate now the second one, you keep the other one constant. That's what is also happening here. For example, 0,2 is a what? It's a constant. We kept it outside. So here we differentiated e first. Remember, it's the e to the power minus x minus 3t. If you differentiate this one with respect to x, what are you going to get? We are going to get minus, isn't it? E to the power minus x minus 3t. Why? Because t is a constant, just a number. That's why we are getting a negative. A negative is coming from the derivative of this one. You also differentiate minus x, you get -1. So which means this is the first derivative. We differentiated e and we kept the bracket of sign a what? Constant. So we are using product rule here of differentiation. We are using product rule. Are we together? When you differentiate the first one, you keep the second one constant. You don't differentiate sign 3t. Then the next step, now you keep the first one that you differentiated, which was e to the power minus x minus 3t, this one. You keep it constant. When you keep it constant, you differentiate this one. That is product rule. So now I'm going to differentiate sine x plus 3t. Then you get this one. When you differentiate sine, you are going to get what? Cos x plus 3t. And 0,2, we kept it outside because it's just a number. It's a constant. Any question for the first one?
It's not sure.
Yeah.
It's not make sure. So you're saying, okay, the first one, it's constant. We took it out.
Yeah. 0,2 it's out because 0,2 is multiplying everything, isn't it?
So now we
it's a number.
differentiated the first one, the x, ne? And then x to
we differentiate
e to
one.
the power negative x, which remains the same, but will multiply by the negative because now the x is going to be 1. So we multiply by -1. That's why we have negative behind the first E, but it's
Yeah.
still the same.
Yes.
So the
When you differentiate an exponential equation, it's like this. It's going to be e to the power minus x minus
oh
3
product rule.
multiplied by the derivative.
A.
What is inside this bracket? Derivative of minus x minus 3t. When you differentiate this one with respect to x, it's going to give you -1.
It's making sense because product rule, it says f multiplied by prime g plus prime x multiplied by prime f multiplied by prime g, and then plus f prime multiplied by g. So the first f, you write it as it is, you derive the g, plus the f, you derive it, and then the g remains the same. Oh, now it's making sense.
That is it. You differentiate the first, keeping the first one, the second one constant.
A.
Plus, now you keep the first one constant, then you differentiate the second one.
Now it's making sense. If it's product rule.
That's product rule, isn't it?
Yeah.
That's product rule. So when you are done there with your product rule, now that is what your dy dx look like. We are agreeing, isn't it?
Yes.
Now we want to differentiate again the same equation twice, like just what we did. You get it? Yeah. So we are differentiating this again.
Sorry. Can I ask? So we're using product rule because of
Yes.
the type of question we have. But if we had something like cos x xy, we're going to use chain rule.
You just use chain rule.
Or it
Here,
depends on how
the product now, yes, now we are going to use product rule because we are having a function in terms of x. We are having another function of sine in terms of what? X. Then if you are having two, these are two different functions. Definitely you must use product rule.
So it was maybe cos
if you
x.
only given one function like sine, this one, you just use the chain rule. Only. There is no product rule there. You
Or
differentiate sine, cos, and you differentiate what is inside, we are done. But with this one, each and every time you are supposed to apply what? A product rule. Because of the two functions of the exponential function and the trig function.
Okay.
Yes. So now we are done with the first derivative of the y. We are supposed to have the second derivative partial, but this is a partial derivative while we are keeping t as constant. So we are only deriving with respect to x. That is with respect to x. So which means we are differentiating again this equation again, second time. Okay. So let's go. 0,2 is still outside, isn't it? Yes, 0,2 is still outside. So if 0,2 is still outside, now we differentiate this first one, keeping the what? The second one constant. Can you see? So when you differentiate this one, you are going to get negative. And already I have a negative there. So negative give you a what?
So we're still derivating in with respect to x again.
Yes, you are still differentiating because it's the second time now. That's why it's a 2 now, this time. Can you see?
If I may ask, why do we have to derive it twice?
All right. The reason why we have to derive twice is because our equation must come into this format, whereby we are equating this second derivative with respect to x. It must be equal to the second derivative of y with respect to time. We are going to equate those two equations.
Okay.
Yes, that is the mission. First, you get the second derivative of y with respect to x. We go and differentiate again the same equation with respect to time, first and second. Then we equate the what? The equations. Then we are done. Everything will come out.
So we're using that formula because it's the formula for
Yes, one
negative.
dimension wave equation. So this is the formula for one time. If we are putting everything in this format, then we know we are done. If everything goes in this format, then we are done.
Okay.
Format that we want. So
No.
now we're working on the right hand side. So let's work on it. So we are here. Now we differentiate again twice. We got a positive here. So from there, you get a positive, which means here, now we are getting a positive, negative, negative. This one, we are keeping it constant. This is the constant. I did not differentiate it. Constant. Then, now I come where there is plus. Can you see plus, this one?
Mm-hmm.
Can you see that there's a negative? Where there is plus, this one, can you see that here there's a negative now? Do you know where that negative is coming from? Where is the negative coming from?
Mm-hmm. Is it not coming from when we derive the second one?
So what do? We keep the first one constant, then we derive the what?
But on this one,
Mm.
you kept the negative negative e to the power negative you kept e negative x minus yt constant the way it was, right?
No, we are still here. We are not, we have not, we are still, isn't it? We are still, we have differentiated this one, the exponential. We kept the what? We kept the sign what? Constant, isn't it?
You know what? I'm forgetting that this is the second derivative.
So
It's
this is the
because
first derivative. We kept the sign constant while we were deriving the second. We kept the sign constant. Now the second step is saying we keep the first one, this one. But what we are not here at this term, which I'm showing you here. We are not there. We are here, this one. We keep now this one constant. Can you see?
which one?
Minus e to the power negative x. Isn't it? It was the one which we differentiated here first. Yes, then we got a negative, a positive. Now I must keep this first one, this one, constant. That's why there's a negative here. This negative is coming from there. You are adding, you are saying plus. Isn't it product? It says plus. What is plus times a minus? Because product, you are saying you are adding, you are saying plus, bracket. Here there is minus e to the power minus x minus 3t, like that. Then when you differentiate sign, what are you going to get when you differentiate sign? Cos what? Cos x. Cos x plus 3t. That's what we are going to do. So positive times negative. Positive times negative give you this negative, which I'm referring you to here. It's coming from here, positive times negative.
So you derivated the first one, right? Which you multiplied the negative, the first one there. No, not that one. The first one. Just after the 0.2 bracket. That one.
Mm.
So when you derivate it, you multiplied the negative 1, because it's with respect to x. You got -1, which you multiply by minus the negative e. Now you got 2. You got
You got a positive.
So, but why is it 2 there?
Where?
Why 2e to the power negative?
Where is there 2e? We are not there 2e. We are still here.
Okay,
We are
the
not
first
there.
part. So now
I'm
on
not
the first part,
here.
when you derivate the negative x, you got -1. You multiplied it with the negative e that you found on the first equation. That's how you got the positive.
Which positive are you talking about?
The first part there.
Yes, that one, yes. I have agreed that one. That is negative times negative positive.
Okay, the second one remained.
I'm referring to the negative, the second negative.
No, the second negative is because you took it as it is, and then you put it there. So you said minus and plus, you got minus.
Yes. So that was the first part. Now we want to differentiate the second part, this one. We are done with the first part. So here there are two product rules. On the first equation, there was only one product rule. On the second derivative, now we are having two product rules that you must be dealing with. So in other words, you are going to be having 4 terms, which you are going to be coming up with. So now we are done with the first 2 terms. Now we are waiting for the other 2 terms. Right. So which means if I differentiate this one, let me see this one. What do you get when you differentiate e to the power minus 3t? But now it's a positive. E to the power minus x minus 3t.
With respect to what? To x?
We are still differentiating with respect to x. Only the exponent. E to the power minus x minus 3t. What do you get?
You get negative e to the power to negative x minus negative 3t.
Exactly. That's what we are saying. So here I'm going to write now to say it's going to be negative e to the power negative x minus 3t. I'm done. Then I must keep the second one what? As a constant, isn't it? So which means I must keep cos x it's cos x plus 3t as a constant. That's what I want to keep it. I want to keep x plus 3t as a constant.
Now I'm lost. Why are we doing it again? Why are we derivating it again? Because we did it the first time, right? The second time we did it. So why are we adding negative this one again?
I am saying the first part that we were differentiating, we were dealing with this product rule for only this side. This side. That's why when we got these terms, which are here, it was only the first part. Now we are dealing with
the second part.
This part.
Okay.
So that we get the other 2 terms, so that there are 4. You get what I'm saying?
Mm.
So which means you differentiate again. Now we are taking plus, which means this one is now a constant. Take it as it is. Then you differentiate cos. When you differentiate cos, you are going to get what?
Negative sign.
Negative sign. So that's why this plus, which is there, it's neutralized. Instead of saying plus, it's affected by that negative from the sign.
Yeah.
So it will minus again. You get it?
Yes.
That's what I'm saying. So there it will be minus. So it will be minus.
Cos
It
3x.
will be minus e to the power minus x what? Minus 3t. Then where there is cos, now we put a what?
Negative sign.
Negative sign, because we differentiate. And the negative sign is this one. It was supposed to be a plus, but
Yeah.
because of negative, now the plus has been neutralized.
Yes.
So it will be negative sign bracket x plus 3t, like that, as one expression. It's one line. And then everything is under the bracket, the square bracket. It's under the square bracket. This one, it's closed. Means I'm applying by 0.2. Still under the square bracket. Still under the square bracket. That's where. Then from there, we want to simplify. We group like terms together, the ones that we can deal with and the ones that we can cancel out. Check sine 3t. Which ones are canceling out from those four terms inside the square bracket?
The first
So
one.
I'll put them with a different color so that they are easy to identify. So let's start. The first one, I'll put it in green, this one. It's a positive. It will cancel with which one? With this one, the last one. With
Yes.
the what? The negative. They cancel out, isn't it?
Mm-hmm.
Which means they are gone, these ones. Okay? Now we are left with minus, the ones with the cos. So it's a minus and a minus. That's why the 2. Can you see where the 2 is coming from?
Mm-hmm.
Mm-hmm. Are we together then?
We are together on the first part only, where we have the 2e.
So
now,
if ones
why?
are not canceling, yeah, you're right. They are adding out, which means there should be a sign mistake. Let's correct it. Let's correct it on our signs. So the first one, for sign, we said we are adding. So which means plus. Then we differentiated the first one. And then because of the negative, it came negative, which is correct. We kept that one constant. All right. Then plus. Okay. Yes. So the question is, why are we having a 2 and also a 2 cos, isn't it? One was supposed to be vanishing, isn't it?
Yeah.
And the other one is not disappearing.
We were supposed to have negative 2e
Mm.
to the power negative x negative y cos and then cos x plus 3t. Not the first one.
The sign is not supposed to be there.
No.
Yes. So you are correct in that way, isn't it? So let's
Erase.
yes. So let's make them vanish. It's correct. So which means this one, it's going out because of the negative, isn't it? Going with this one. It's going out. All right. So that is the first step. So when we are simplifying it now, we are coming here where we are now adding only the negatives. So negative E, yeah, I did not shade nicely. Let me shade so that it does not confuse us. This one is out, and then here it ends here. This one is out. Then we cancel these ones. They are gone. All right, so now we are left with negative E to the power minus cos 3t. Then we add the negative, give you minus 2. So we are here.
Yes.
We are there, isn't it? So this is our second derivative. So which means now we are done with the first part of the partial derivative with respect to x. Now we want to find the partial derivative with respect to time, t. Isn't it?
Yes.
Yes, with respect to time. So let's go, we differentiate the first equation with respect to time. So this is the first equation. And remember, our mission is to say the partial of y, second derivative, partial y, with respect to time squared, should be in this format, which is squared y with respect to x. So already we have found the partial derivative of the first one with respect to x. So we have found this one, the first one. Now we want to look for the second one, which is
So what is the v squared? Is it the constant?
the v to be the constant. So any number that will be left hanging, that will be our v. So don't worry about the
v. Is 0.2.
No, it's not 0.2. After we've equated that number that we left, yes, not now. We have not yet equated.
Okay.
After the left and the right, what will be left in between should be the what? The v.
Okay.
So first we have our partial second derivative, which means partial squared y with respect to x. Now we want the partial squared y with respect to time. So we go to our equation for time. So the first equation is here. So now we want to differentiate the first with respect to time. So we go to the original equation. Original equation, which we were given, it's 0.2 e to the power minus x minus 3t that. So we can write it here so that we can differentiate it properly while we are seeing it here. So our y, which will be equals to 0.2 e power minus x minus 3t multiplied by sine of x plus 3t. This is our equation. All right. So let's differentiate it while we are looking at it. So where there is 0, this is the constant which is outside. Now we are differentiating with what? Time. Which means x is now a what? A constant. Can you see? X is now a constant.
A constant.
Yes, so you must know x is now a constant. So which means you are going to get the same exponent to come back. This is the same exponent. It has come back. E to the power minus 3 xt, while we are keeping sign constant. So which means you are differentiating this one. You keep this one a what? A constant. This is the constant. So when you differentiate from chain rule, you have minus 3t there on top. When you differentiate minus 3t, you are going to get a negative one.
A negative 3.
Now we are done with the first part. Now we want to differentiate this while we are keeping this one constant. So we'll keep the other one constant, then we differentiate the other. With respect to what? To time. So we are differentiating with respect to t. So that's why the negative came, and then we are having this one. Now you say plus. Then when you differentiate this side, you are going to get the same equation. It will be plus e to the power minus x minus 3t. This one you keep it what? Constant. When you differentiate sign, you are going to get what?
Cos
of the same thing inside. But because of chain rule, there is 3t here. When you differentiate 3t, you are going to get a what? 3.
we're gonna multiply
3, that 3 outside the bracket. Isn't it? This is the 3 which is here. So that 3 is this one, which you multiplied outside the what? The bracket. So there, our answer is going to be, so we erase that one. So which means now if you are completing this one, it will be plus cos bracket
x plus 3t.
Plus 3t. Then you close your what? Your square bracket. Are we together then? Now you differentiate now again, which means now we are going to be having 4 terms. We are going to be having 4 terms. So which those 4 terms are coming from here. We differentiate this one. So it will be minus 3, which is already there, plus another minus 3, which is coming after I differentiate here. Then it's a positive one. 9. Can you see it? Remember, I'm differentiating now this one, keeping this one constant. So this one, I keep it constant, then I differentiate this one. So I'm already having minus 3, and then is another minus 3, which is coming from chain rule here on the top.
Yes.
So that's why it's minus 3 times minus 3. It's what? Positive
3.
9. Positive 9.
Yeah,
Then
3
you
times 9.
just copy sign as it is. Sign as it is. So it will be sign x minus 3t. Then now we are differentiating the second one, this one. So we keep the first one what? Constant.
Yes.
So if we keep the first one constant, it's minus what? It's minus 3, this one. E to the power minus x minus 3t. Now I'm differentiating what? Sign. So if I differentiate sign, what do I get?
Cos.
Cos. But the cos is going to be multiplied by a 3. And already
Yes.
there is a negative here. Okay. So that 3, which is going to multiply by cos, it will be times 3 here. That's where we are getting the 9 from. So negative 3, then it's a 9. Then you get cos what?
X plus 3t inside the bracket.
Yes. Cos x plus 3t inside the bracket. That was the first differentiating only the first part. We mean this one only, just from here to there. And I'm left with this part to differentiate it again. Can you see? On the right. So we are done with differentiating this product. You get 2 terms. There must be 4 terms in total. So now we want to differentiate again this part so that we get the other 2 terms. So you do the same plus what? You do the same. What are we going to get? Plus what?
The first one is gonna be it's gonna remain the same, right?
This one. Yes. No, we are now differentiating this one, this part.
First,
It can't be remaining the same. We differentiate the first, we keep the first one constant.
so it's gonna be -9
Yes,
e
negative
the
9.
power -x -3t.
Sorry. Just zoom it now. All right. You said it's going to be negative?
9.
So -9. Yes.
E to the power -x -3t.
E to the power -x -3t. Yes, it's correct. Multiply by what? We keep the cos what?
The cos bracket x plus 3t the same.
Constant, yes.
Mm-hmm.
Let's put the bracket, which is cos bracket x plus 3t.
Mm-hmm.
We close. All right, so we have differentiated that part. Now we are left with the next one for differentiating the second one. So which means you are going to keep the positive
3t 3e
yes.
to the power -x minus 3t.
So when you differentiate cos, what do you get?
Negative sign.
Negative sign. So that negative sign will affect the positive on the e. So that's where the -9 will come from, isn't it? So let's put it in writing. Can fit it down like what we did. So it will be -9. So it will be -9 minus 9 e to the power -x -3t. Instead of cos, now we are having what?
Sine.
Yes, that is the only difference. Sine bracket x plus 3t. You close your bracket, then you put the square what? Bracket. Then you are done. Then now we are identifying the things that are common. So we want to identify in the bracket which ones are common. Can use another color so that we circle them, which are cancelling out.
The first one and the last one.
The first and the
last one.
They are cancelling, isn't it? So this one goes. And this one?
The first one goes out.
Also goes, this one. So if these ones go, which means you are left with -9, -9. Then it will be minus what? 18.
A minus 18. X e x to the power negative x minus 3t cos of x plus 3t.
Yes. So you are happy there, isn't it?
Yes.
So we are having those 2 equations. Now you are going to compare them now. So which means you are comparing the second partial what? Derivatives. So let's compare them together. Right. So which means here on the left and on the right. So on the left, we are having That is 0. You can use a different color here so that it does not confuse us. So on the left, you are having partial derivative with respect to y. So which means you are having a 0, comma 2, what, this is your left, is equals to the right. The right, what did we have on the right? This one, 0, comma 2, multiplied by negative 2e to the power cos 3x plus t. So it's just
With respect to x, yes.
with respect to x. So everything is the same, which is 0, comma 2. Multiplied by negative 2e to the power minus x minus 3t cos x plus 3t.
Mm-hmm.
Cos x plus
3t.
put your bracket, then you close.
Mm.
That's what we have found. Partial x is equals partial squared y with respect to t is equals to partial squared x.
With
y
respect.
with respect to x.
Mm.
So there was a negative, right? So now we are manipulating this. We are saying if there is going to be the left-hand side not balancing with the right-hand side, that is the number that you are going to equate to what? To v, isn't it?
Mm-hmm.
Yes. And it must be on the right-hand side of the equation because v is always on the right-hand side with the partial x multiplied to the partial y with respect to x. Right. In that case, which means if I want to eliminate on the left, I'm having already a negative 18. Can you see? Everything is the same, but it's only differing here.
The negative 18
Yes.
and the negative 2. Oh, you divide them.
Only differing there. Can you see?
Oh.
You are not going to divide, but you are going to multiply. You don't divide. What are you going to do to make those equations the same? You get what I'm saying?
Mm-hmm.
So which means I'm going to multiply the equation on the right by what?
The equation on the left.
This is the equation on the left. This is the equation on the right. The right hand side is this one. This is the equal sign. This is the left hand side. So we are saying this, they are only differing here. Here there's negative 18. Here there's negative 2. You want to balance negative 18 and 2.
Mm.
So where can you multiply? You can only multiply the right hand side according to the equation. If they are differing, you can only compensate by only multiplying the what? The right hand side. That is the only equation which you can multiply so that it can be equal to the left hand side. This number you are going to multiply by, that is your v squared. That's what I was telling you, that I will show you how we are going to get that v squared. So which number are you going to multiply by so that those two equations are the same?
0,
I'm going
2.
to multiply negative 2 times 9 so that this is negative what? 18. Because these, they are only differing at negative 2 and negative 18. Everything is the same, isn't it?
Mm. So we
So
must make the two equations equal. Find a
equal.
number that when you multiply the right hand side, it will be the both the left hand side and the right hand side will be equal. That's gonna be our v.
Mm-hmm. So once you find that number which you are going to multiply, it's not your v, but it's a v squared. That
Of v
number
squared, yes.
v squared. So you found that number which I must multiply to make the equations equals to be v squared. So you write it in this way to say, in order for my equations to be equal, I multiplied the left and the right by this constant, which is 9. So
Okay.
that now we have put your equation in one-dimensional wave that is given by this. That number which you multiply by was v squared. So already now you know the speed of the what, which they were looking for, this one. They were asking, deduce the wave speed form. What is the wave speed? That's v. You get it?
Okay.
That is the wave speed which they were looking for. And remember, you were given your displacement of x in centimeters. So it's not meters per second, it's centimeters per what? Per second. So you must take note of that as well, because your units were centimeters. So once you have put in that equation, you found that that one is 9. Now you can calculate the what? The speed. The speed, you can calculate it, the wave speed. Because v squared is equals to what? 9. So
Yeah.
my speed, v, will be the square root of what? Of 9. What is the square root of 9?
3.
3. So which means the wave speed is 3 centimeters per second. Why centimeters per second? They told us the displacement x is in centimeters, not in meters.
Oh, I think we overused time. It's now 10 past 8.
All right. So that is it. We had to finish this one because we couldn't leave it hanging. We can't start on this question again tomorrow. So that is the first part. Now you have your V. You indicate your V is 3 meters per second. You answer it. The last question was the propagation. Is it moving towards the positive or negative? I told you if there is a plus here, then it's moving towards the what? The negative direction. Okay?
Yes.
Yes. So the direction of propagation is determined by the sign coefficient of t, only of t, the coefficient of t. If the coefficient of t is plus 3, which means it's to the negative. If it was negative 3, which means it's moving towards the positive x direction. So in our towards the what?
It's
Negative.
moved to the negative direction because of positive.
Positive. So I will share the PDF and the recording, then you can start answering and writing question number 2.
Okay.
So we calculated the wave speed and we have calculated the direction of propagation towards the negative x direction.
Okay.
All right. So we can stop there. Is it fine? I don't think there are other questions.